This is the video for Mod 3 Lesson 5A, Solving by Inspection and Taking Square Roots. In Mod 3B, we're going to be looking at solving quadratic equations. And one of the things we're going to notice is the relationship between the solutions to a quadratic equation and our x-intercepts of a graph. We're also going to see a method today called solving with square roots, where we're using what we used with simplifying radicals to find a value for x. So one thing we're going to see, which we saw earlier in this school year, was talking about quadratics. Quadratics, if we look at the equations, we sometimes have quadratics in standard form, vertex form. We can even have x-intercept or factored form. And we're going to find that when we solve a quadratic equation, let's say, for example, an equation that maybe looks like this, right, where we have more than one variable, what we're eventually going to find is that we can actually rewrite an equation so it's in a form where it equals 0. And really, it's the same as finding the x-intercepts on the graph. So if I was to take this equation and look at the graph, which I have right here, where the graph crosses the x-axis, that's the same as the solution to the equation. So in the first graph, we see that we have one x-intercept here. This is at the point 4, 0. And this would be considered one solution. So we have one x-intercept that happens there. So this, if we were to solve this as an equation, it would have only one distinct solution at 4, 0. Other possibilities we have is we can have two solutions or two x-intercepts. And that would be, for example, if we take this equation right here, graph it, we can see it crosses at -3, 0 and 2, 0. So this would be an example where it has two solutions or two x-intercepts. And then we can have a situation where we graph it and we have no x-intercepts. So if I was to go ahead and solve this, maybe set it equal to 0 and see what solution we would have, we don't have any value I can put in for x that would make this true. So this one has no x-intercepts. And so we can have one of these three scenarios. You can have it where there is one solution, two solutions, or no solution. One question we can have posed is, if x squared is equal to 4, what solutions for x make the equation true? So we can think about this a few different ways. We can do guess and check, but what we're mostly going to focus on the second part of this video is how to solve using the square roots, which is what we practice with during Mod 3A. So this is basically saying, what number can I square to get 4? And there's actually two different values that would work. I could square 2, and 2 squared is equal to 4. But I could also square -2. If I square a negative number, I'm going to get a positive. And so we actually have two different solutions for that. What we're going to find is once we start doing more and more problems and they get a little more complex, we're not going to really want to use guess and check. So these are some steps that we can use if we want to use the solving by square roots. And one thing that we're going to point out here is that notice for all of these problems today that you're going to look at, there's only one variable, or x is only listed one time. If we have an x squared and an x in the same problem, it's going to be a little bit different of solving. We can't use square roots, or we'll have to do something else. So if I have, let's say, x squared is equal to 4, like I just saw a moment ago, my first step is going to be getting x squared, or the quantity squared by itself, which it already is on a side by itself. I'm then going to do the inverse to both sides, or get rid of that variable being squared. So we're going to take the square root of both sides. So once x squared is on a side by itself, I can take the square root of the left, the square root of the right, and the square root of x squared is just going to be x. And then when I take the square root of 4, we know the square root of 4 is 2, but I have to include a plus or a minus, right? Because like we just saw a moment ago, you could have positive 2 that we square, or you can have a negative 2. So either one could be a solution. So our answer is actually plus or minus 2, or you can write it as 2 and negative 2. Or you can like list them out, you can list them even separately from each other. But basically we have two solutions for this equation. What we're going to start to see is sometimes we're not doing the square root of a perfect square like we already saw in the previous mod. So this is going to be the same steps, we just have to do a little simplifying. So I have x squared is equal to 24. The variable is already on a side by itself, so we're going to go ahead and square root both sides. I'm going to get plus or minus the square root of 24, so I have to remember that plus or minus, but we can't leave our answer as just root 24. We have to think about our perfect squares that we already talked about. So I have here plus or minus. I'm going to do a perfect square and a non-perfect square. So our perfect square is going to be 4. So 4 times 6. And again, even though 8 times 3 is 24, we want one of them to be a perfect square. And so our answer is actually plus or minus 2 radical 6. So we actually have here two different solutions. We have 2 radical 6 and actually negative 2 radical 6. So we actually have two different answers. You can write your answer either way. They would both be correct. For the second example, same idea. I have x squared is equal to 48. I'm going to take the square root of both sides because x squared is already by itself. I have plus or minus the square root of 48. And then now I'm going to go ahead and simplify that radical. 48, the largest perfect square, is going to be 16 and 3. And then the square root of 16 is going to be 4. So my answer is actually plus or minus 4 root 3. So again, both answers have to be listed. It's either 4 radical 3 or negative 4 radical 3. All right, for the last two examples, same thing. So we have x squared equals 36. X squared is on a side by itself already, and now we're going to take the square root of both sides. On one side, I have x. On the other side, I have plus or minus the square root of 36. And then finally, when I do the square root of 36, that's actually a perfect square. So we don't have to break it up into anything else. The square root of 36 is just 6. So our answer would be plus or minus 6, or you can write it as 6 and negative 6. For the last example, this one has a lot more going on, and it's really tempting to want to like square this out and distribute the 3. But if we solve using square roots, we can first check if we're able to do that. Notice the x only appears one time in this problem, and so that tells us that we can use square roots. So we're going to go ahead. I'm going to highlight this quantity being squared. And we're going to go ahead and get what's being squared by itself first. So if I look at what's actually happening here, to get rid of that quantity being squared, it's getting multiplied by 3. We're subtracting 6. We're going to solve it just like a linear equation at first. So I'm going to actually isolate what's being squared first. I'm going to add 6 to both sides. I have 3 times the quantity x plus 2 squared is equal to 24. And again, I'm still getting this quantity that's being squared by itself first. We're then going to go ahead and divide by 3. I have x plus 2 quantity squared is equal to 8. And now I have what's being squared on a side by itself. We're now going to go ahead and square root both sides. So on one side I have x plus 2. On the other side I have plus or minus the square root of 8. And then the last step was to solve for x. So we're going to go ahead and subtract 2 from each side. And we have here negative 2 plus or minus the square root of 8. But what we're going to see in our last piece is that we can't leave our answer as just the square root of 8, right? We have to simplify that out. So if I go ahead and simplify this, and I'm going to go ahead and erase this here so I can have a little room. So if I go ahead and I'm going to move this over here, I have negative 2 plus or minus 8. I have square root of 8. I have to simplify the square root of 8. So negative 2 plus or minus and 4 and 2. Negative 2 plus or minus 2 radical 2. And then this is as far as we can go. So even though I see a bunch of 2's here, the negative 2 here does not have a radical. So this is as far as I can go. I can also write my final answer. If I want to list it as 2 separate answers, I can. So 2 plus 2 root 2, or negative 2 plus 2 root 2, and negative 2 minus 2 root 2. So you can either list them separately or write them together. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.